Hello, today we're going to look at how to interface Python code with your C code. And some of the reason for which we do those kind of things is that sometimes you want to do some very complicated task and doing that using the Python language, or maybe you want to just make it the task a bit more efficient, you can write a code into C and then create a library that you import from your Python code, and the Python code can just call the functions from that library. And basically, your code gets faster for the task, and the task is done much more quicker. Here are the steps we are following. The first step is we write the C code, and then we compile the C code into a library. And after that, we load this library from within the Python code. Then we call or import the functions and symbols. Then we can even call the function from the Python code. And the fourth step is how to use some Python object like list and dictionary. There will be a walkthrough, and we're going to follow step by step how to use list, how to pass objects from your Python code to your C code, and so on. Let's start by creating or writing some C code. I'm going to create a function called printed, and the printed function will just display hello. It is a void function. The function doesn't return anything and doesn't receive any parameter. Since we're going to display a message, we import the stdio library. Then we call the printf function to display our message. Now you can create a library from this function, but I want to make things more interesting. Let's say I'm going to create a function called greeting, or just greet.c. And the greet.c function will just say greet, doesn't receive any parameter. We display the message greet. And that's it. I'm going to include the stdio library because we're using the printf function. Now that we have these C files, we can compile all these functions and turn them into a library. So we can share the library with other programs like the C program, or any other program can call the functions that are in the shared library. Let's create a shared library. I'm going to copy this command and we'll explain. So basically, we use the GCC compiler with some error flag options, error options. And what is the most important here? We have to compile the Python code with the C99 standard version. And we tell the compiler we want to create a shared library. You can do some search on what are shared library and static libraries. And the output file name will be lib funny.so. Then we have to make the library position independent code. Then here we have the include directory for the Python libraries, but for now we don't need it because we're not using any Python object or functions from our C code. I'm just going to delete that, and that's it. Now you have the sleepfunny.sco shared library. We can load it from our Python code and call the different functions declared in it. Let's create a file called main.py. I'm going to add the hbang and specify the binary version for the Python. So user being Python version 3.9. So this is the path to the Python interpreter. And next, we're going to import some useful library, the C types library. You can do some search on the C type library module, I want to say module. The C type, the C types module, it allows like calling functions in DDL or shared library. From the Python documentation, you can go and read on. Now we call the DDL or the py DDL function py DDL. Then we specify the path to the lib fun funny SEO. So this will return an object representing the shared library. Then we can use this object to call the functions. I'm going to create a variable called the lib or my custom lib. Then the next step, since we knows what are the functions in or the symbols in this library, we can call our different functions. So my custom lib dot print it. No parameter needed to be passed. We don't need to pass in any parameter. And also, if you want, you can even call the greet function. Now let's execute this Python code. I'm going to turn it into an executable by changing the permissions. And let's see. Yes, it displayed hello world, then greet. Yes, the hello world, there is no line break. So I'm going to go in the C code and change it. I'm going to add a line break. Let's compile the code again and create a new shared library. And after that, we can run a Python code. And yeah, you see. So here is what happened. You create whatever functions you want. And those functions, since they are available in the global scope, they can be accessed from outside. So a program can load the libraries and call the functions or access different objects or variables from within that library. Now let's make something a bit complicated. Let's say we want to pass some parameter from our Python code to down to our C code. Instead of printing the message hello world, what if we want to pass in a parameter to a print it function, and the print it function just displays the message using the printf here. Then when you change the prototype, it will receive a pointer to a string, and we call the hello world, we call the printf function, and we pass in the string. That's it. Now, the next step would be to compile the shared library because we change a function. Okay, you might be attempt to call the printed functions with a strings, but let's look at what's going to happen if you do that. Or let's just execute the Python code without passing any parameter and see what is the error that's going to display. No error yet. I'm going to pass in the message cool code. Yeah, so we see that when the Python code execute, there is a C that displayed. So we have some problems. Why this is happening? It is not behaving as expected. The reason for that is we need to also tell Python that this function receives some types as parameter. So we have to configure this object. So we have the arg type attribute. We set it to a list, and we say C type. It's going to receive as an argument a C string. So a C string is a pointer to a character. So a C char P pointer. So this tells the Python interpreter that this function is going to receive one parameter. If there are other arguments or parameters, we have to specify their type in the list so that the interpreter would know how to call the print function. I'm going to execute the code again. And here we have some kind of problem. It says file, and it says argument error, class wrong type. So there is something for us to do is to say that this is a, a string of bytes. And now the code works as expected. So if you pass it like that with the string, this will pass in a Python object. This will cause the interpreter to pass in a Python string object. This is not what we want. The equivalent of a C string in the Python code would be a byte string. So we add this little specifier, a B specifier in front of the string. So we have the Python code calling the C code. We can even do some more complicated things. The we can have some return types. For example, let's say when this function prints something, it's going to return a value. Let's say going to return 100. We have these things displayed, and the return type will be an integer. Yes, we can also tell the Python interpreter that this function has a return type, and the return type will be a C integer. So we say C types, so C int type. Then we can receive, when you call the printed function, we can receive the resulting return, the result inside this variable I'm gonna call num, and use the built-in function of Python and display this number. Let's see if it works. But for now, let's compile this code again and run the Python code. Oh, yes, we've got a problem. It says that attribute error, undefined symbol, print int. Yes, there is a typo here. It is printed. I'm gonna clear it up again and run the Python code. And that's it. You can define C functions, and if you have some parameter to pass to that function, you might want to specify it in the Python code. So I am going to call this configuring your library, um, your the symbols in order for the Python code to know what to do. Let's do another example. I'm going to create a function add.c. This function returns the sum of two integer numbers. Then I'm going to compile it again. So this will create a library with the star.c. This will add up all the C files into this library. I'm gonna compile it again. That's it. And then from our Python code, we can call our add function. So I'm going to import it. The add func is equal to my custom leaf add func. You have to make sure that the symbols from the library is correct. If you don't do that, you might have some errors. So I'm going to tell Python that this function has some arguments, and the arguments are some C types integers and C type integer again. These are the primitive type from C. So you can do some search on that. Next, we say the add func, the functions will also have a return type. So return type will be an integer. Till now, we're not using Python object. We're just using um, a plain old C. Then now I can call the add func, then pass in some parameter, for example, an integer, 15, then 125. Let's compile execute this code. Undefined symbol. I'm going to recompile the library again because we made some changes in order to include the add function and run the Python code. It says undefined add func. Yes, there is a typo. The symbol name is add. Here we name the function add, so its symbol name from the library is add. Let's recompile the library again, okay, and run the Python code. And here it is. 50 plus 125 give you 175. This is basically how this thing works. Now, how to create or pass some Python object down to our print function. There are multiple ways of doing that, but first of all, let's start by by changing these parameters and passing some Python string object. I'm going to delete all this code. And now what is here, since we're going to do those call use some Python objects from our C code, we have to include the Python C library. So here I'm going to include python.h library. We would have to tell the compiler where to get this python.h library. But for now, we want to make a tour on the GitHub repository of the CPython, and I will explain some basic stuff. Where are these libraries or these objects located? Where can you find them? You can go on the Python website. This is one way of reading. You may want to read the docs, but I prefer to go in the repository if I think that suits me best. Let's go in the repository, and here you have CPython. CPython is the compiled version of Python from the C programming language. So they've used the C programming language to implement the Python specification. Now, there is some interesting directories. I'm going to look in the include directory and the object directory. These are the directories where we have those object defined, and we've also some API related functions needed to work with the object. Here, for example, we have what we call it, the list object, the dictionary object here. We have the file object. All these things are object. We even have the object where it is. Here, we have the object type. Yes, here. So the object type can be cast into all other objects. So you can, a list object is an object. They all inherit from this object type. And we can pass this object between functions, but we just have to keep track of the type of the object or the specific type of the object. and in order to be able to make changes. For example, if you go in the list object.h, you see that there are a bunch of things declared. We have macros, we have, let's say, we have these functions. These are API related functions. So you want to look into the include directory. This is where you can find all the API related things. For example, we have a C function that allows you to create a new list, and you specify the size of the list. You have a function to return the size of the list, get an item, and what else? You have a function called set an item, insert append, get light, sort the list, and revert. You can even notice that all these functions receive some kind of Py object pointer type, and it will be interesting to look into these things. So when you pass in a Py object pointer to, for example, the Py list get item, what will happen? The Py list get item function will cast the Py objects pointer into a Py list object. So as we said, all the Python objects inherit from the Py object. So they use some fancy macro stuffs in order to be able to do that. So basically, you have this Py list get item. You pass in the list in a C way. We don't have these things like the object name dot the function or the attribute name. We don't have things like object-oriented programming in this this C standard version. So we use function calls, and we have to make sure that we pass in the correct types. In the case of PyList get item, we pass in the Py object, which has to be a list, and we also have to pass in the index of that object. So for Python, we have this Py size s size t custom type. So this will be defined. The type will be defined depending on the platform in which the code the your code is being compiled. So if you want to work with Python list, you just need to look into here and use the functions you want. You have this also PyAPI func macro. Depending on the platform, this macro will add some specifiers to let to in order to export the function, for example, on Windows machines, but this is not even required on the Linux systems. But here, for example, we could have add some things specific for the Windows platform, but we didn't because we're on the Linux platform, and this is not required for now. The objects are exported, and we don't need any additional specifier for the compiler. Let's look into the implementation of this function, the Py list get item. In order to find the function definition, you return and you look for the object folder. Let's scroll down. We have where it is, list object. Here it is, list object.c. So this is where all these functions are defined. There are static functions. These functions cannot be used outside of They can't be, you can't call this function outside the file scope. So don't try to use the static function from your code. Only the macros and the functions. Yeah, we have these macros. You can't use these macros starting with the underscore or the function starting with underscore. These are private to the file. And these functions are the ones we can use. For example, we have the file list new, then we specify the size of the list. And if you go in the header file, you would see that this prototype is defined, is declared in the header file. And this is how they we have some code, some macros, and a lot of things. But yes, here the function we're looking for is the pilot get item. And you see that we receive the pi object pointer, and all pi objects have certain attributes. For example, a pi object can have the object type attributes, and from the object, these are structures. So you can say objects type dot, you can say object, then you access the object type, then you access the object type name. So we use a macro. For example, we have these macros by list check. This will check if this object is of type list. If it is not a list object, this macro will return false. So we even have these things defined in the header file. So the get item, then we have some codes, and then we have this by list object. We access an array. I don't know, maybe this is, yes, this is some kind of, this is an array. And the object at index I get returned. So whenever you want to use the return object or the return pi object, you might want to check for this type in order to determine what are the operations you can perform on this object. Let's return back in our include folder. So where it is here, the include folder. And so when you want to see the API, the object API function, you go and look for the include file. But if you are interested at looking how these functions are implemented, you may look for you may look for the object, you may look into the object directory where all these functions are defined. And yes, that's it. Let's go back in our code.